I'm Michaela of Group 3. The problem we worked on this week is a sequence is defined by b of n equals ln of n, where n is greater than or equal to 1. The question is the sequence convergent or divergent? And explain. So for this problem, we can use the monotonic sequence theorem, which states that if a sequence is monotonic, which means it is either increasing or constantly decreasing on n is greater than or equal to 1, and bounded, which means it's bounded above, where any number a of n is greater than m, and any number a of n is less than a number m, it is bounded. So here we can determine that this sequence ln of n is not monotonic. Though the graph down here may suggest that from n equals 1 onward, it's constantly decreasing and approaching 0, y equals 0. When we plug this into the table, we see that actually when n equals 1, b of n equals 0. When n equals 2, b of n equals 0.3465 approximately. When n equals 3, b of n equals approximately 0.3662. And when n equals 4, b of n equals approximately 0.3465 again. So between n equals 1 and n equals 2, it's increasing. N equals 2 and n equals 3 is increasing, but between n equals 3 and n equals 4, it is decreasing again. So we will state that the sequence is not constantly decreasing or increasing for all n is greater than or equal to 1. So the sequence is not monotonic. Therefore, by the monotonic sequence theorem, the sequence is divergent. Now, for the other problem that we were given, consider the series 4 plus 1/2 plus 1/8 plus 1/32 plus 1/128 plus etc. Is this sequence convergent or divergent? And explain your answer. Now your gut feeling may be to say it's convergent, and you would be correct. However, would we be correct in stating that the sequence is convergent based on the monotonic sequence theorem, or by another reason, that the limit as n approaches infinity, here n equals 1, n equals 2, n equals 3, and n equals infinity, the sequence is approaching a finite number? Now, at first, I thought, well, it can be proved by the monotonic sequence theorem. First of all, we can see that it is constantly decreasing from n equals 1. And we can also see that it's bounded below from n equals, or a of n is less than or equal to 4 for all n is greater than or equal to 1. However, a of n is not greater than or equal to 0 because the sequence is approaching 0 but is never 0. So we will state that the sequence has a finite limit of 0, therefore it is convergent. We can state that the finite limit is 0 because, as we can see, the denominator constantly increases in the sequence. Here we have 1 over 128. As the denominator approaches infinity, the numbers in the series will never be a negative. So it will never be below 0, but it constantly approaches 0, which is why we will state that the sequence, as n approaches infinity of a of n is 0. Therefore, the sequence is convergent.